Welcome to the shop. In today's video, I'm going to be making lock collars for the NQALHA. These aren't, strictly speaking, they're not part of the NQALHA production run, but I do include 3 of them with every one that I sell as accessories. Lock collars are used on the NQALHA to control drift of the glass rod or tube when it's being rotated, and in most cases they aren't necessary. In most cases the drift can be managed by other means, and a lot of people don't use them at all. I only use them very rarely, but they are useful in some cases, and so I do include a set of 3 in common sizes with every NQALHA. I also have a total of, I think, 12 sizes that I've made over the time the project has been active, and they're available on request for, if you really need one. So I'm going to be starting out here using 3/8 Delrin plastic. Now you might wonder, well, why would you use plastic on a glassworking machine? Plastic melts and it burns, and yeah, it is a problem. And if you don't watch what's going on and you're using lock collars and you get them too hot, they will melt, they will catch on fire. But they also slide very nicely against the drive rollers with very low friction. And in most cases where they're being used, especially in assembly operations, they don't get that hot. So if you really need to get your lock collars blistering hot, you can use metal ones. And the metal ones are a common off-the-shelf commercial product. Buy them at hardware stores. But the plastic ones that I make are kind of special. They all use the same size screw. They all use an 832 screw. The industrial lock collars, everyone uses a different size screw, and the inch ones use different screws from the metric ones. So anyway, I use 3/8 Delrin, and I engrave the number, the size of the lock collar onto the part to make them easier to figure out which one is which. And anyway, I make the first machining step here, first operation, is going to be done on the CNC wood router, where I take a blank that's big enough for multiple pieces, 10 or 12, or depending on the size of the collar and the size of the blank is how many I make. I make multiple at one time. So here's a blank, and the fixturing system here on my router table is kind of interesting, and see if I can move the camera here so to get a better view of it. I've got an array of evenly spaced holes on the MDF tabletop, and the tabletop was surfaced flat with a surfacing bit in the router, so it's flat relative to the router, and the holes were drilled with the router, so the holes are drilled relative to the coordinate system of the router. And this point in work offset 2, this point is defined as 0. On the 4th axis, this point is defined as 0, but we're not using this today. So I've got these blocks, and the block has 1, 1.5, 2, 2.5, I think. It has some combination of spacings, so depending on how you put the block in place, you can get reasonably close to, get reasonably close, and then you take a wedge and you jam it in, and now the piece is held really solidly in place. And then on the other side, I do the same thing I got a collection of little wedgelets here, and kind of just go through one at a time and try to find one that fits. And a slightly annoying and time-consuming process, but when it's all done, the piece is held nice and securely. And another nice thing about this method, all of the fixturing here is all made of wood. So there's no metal clamps, or if the machine goes out of control, goes crazy, and runs the cutter into the clamps, well, it's not going to hurt the cutter, it's not going to hurt the machine. So I'm going to go over here like all of my machines. This machine is on the network, and I go load up my tool path, which is a known trusted tool path. Don't have power drawbar or automatic tool changer on the router, so it's all by hand. ER20 collet, Chinese, eBay, spindle, driven by a VFD. So I'm going to be doing a tool change. Wrap it into position, and then finger on the stop button. Make sure it's all okay. The measurement device there just measured the position of the tip of the tool, and I'm watching real carefully. So this is the engraving operation, and I'm engraving the number, the size in millimeters. These are going to be 12 millimeter units. And I'm also engraving some marks on the blank so that when I put it in the table saw to cut the blanks into pieces, I'll know where to cut. So, and then in the next part of the operation, after the engraving portion is done, the next thing that gets done is to cut the center holes. And I briefly thought about making up a tooling plate and a fixture for cutting the outside diameter on the wood router, and decided that, nah, it's not worth the trouble. I'll just cut the blanks into squares on the table saw, cut the outside perimeter on the mill, and then cut the slot and the various different counterbore, clearance hole, and tap drill hole for the screw, all on the mill in a special fixture. So just proceeding along with an engraving bit, engraving the size in millimeters. In this case, I'm making 12. This is the 12 millimeter size, and I'm making 12 units. CNC wood router works really well. It works on wood, it works on plastic. Before I got my real milling machines, I even tried machining aluminum on it. And yeah, it'll do aluminum really, 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 really slow. And yeah, I probably could go a little faster on this operation, but I don't make a tremendous lot of these, and I haven't spent the time to really optimize the tool path. So yeah, I probably could speed it up. I could probably run it 4 times as fast and it would work fine, but it works fine now. So moving to the tool change position, totally manual tool change. And of course, since I'm just putting the tool in at any old distance, not precisely located, I need to do a measurement every time the tool is changed. So finger on the stop button, verify that getting to the right position, 25,000 RPM. This gets messy, so I'm going to use the vacuum. At one time I tried making a dust collection hood for the router, and it kind of worked, but it really didn't work, and I kind of gave up on it and just decided, well, I'll just use the vacuum. It's really difficult to do dust collection on a CNC router. Also kind of sucks that the CNC router is in the same room as my glassworking shop. If I am cutting something that makes a lot of dust, like MDF, dust gets everywhere. I'm thinking about maybe putting up a sheet of plastic or something, or I always run my ventilation system when I'm doing routing on stuff that makes dust. So just taking it real easy. Unlike the milling operations where things are clamped in a vise really securely, the Delrin is clamped, you know, kind of okay securely in the wood wedge clamps, but it's not ultra secure. And the cutter is an upcut spiral cutter that pulls the chips up out of the cut, but it also, if I tried being too horribly aggressive, might also pull the part out. So once again, just going slow. Slow as it goes. Running 6 inches per minute. Probably could do 20 and it wouldn't be a problem, but I certainly don't want that bit to grab the plastic and yank it out of the clamping fixture. I typically provide a 10 millimeter, 12 millimeter, and 25.4 or 1 inch with every NQALHA. I already made the first operation on the 10 millimeter. This is the 12. I'm going to make the first operation on the 1 inch off camera because, you know, it's not that interesting, and once you've seen one, they're all about the same. And then I'll turn the camera back on for the second, third, and fourth operations, which are kind of interesting. Not that interesting, but maybe a little interesting. And there we have it. First operation complete. And I get the camera. If the camera can focus on these guys. The engraving comes out really nice. So that's it. See you later. First operation has been completed successfully. The blanks have been cut on the router. The next thing I do here is kind of use the old eyeball to line up those marks that were milled in. Give me a really nice alignment. Of course, the square blanks that I'm cutting are going to be oversized, so I don't need to get it like perfect. But still, always nice to have alignment marks. Using my push stick that has the extra long nose to keep the pieces under control. Checking the alignment marks and adjusting as necessary with the old eyeball. And there we have it. So the square blanks will all be cut, and I'm going to cut the rest of them off camera, and then go over to the mill the outside, and put in the slot on the table saw using a special fixture, and then back to the mill for the holes and counterbores. So a lot of little operations on this guy. All of the parts have been cut to rough square shape on the table saw. So now this is going to be the third operation, where I've got a tooling plate with the 0 set to the rear left corner, standard 0, Z0 set to the top surface, and going to be using a 5/16 3-flute end mill to cut the outer diameter of these guys. So, as I said in the router video, it's always a question when setting up a design like this. How much time do I spend fixturing, building fixtures, creating toolpath, debugging toolpath, and how much time do I spend machining? And yes, I could have created tooling plates for each set of collars that I was making so that I could do both the first and second operation on the wood router. And it probably would have worked really well. I might have had a little bit of problem with the little cutoff pieces getting caught in the router, but it probably would have worked. But boy, that's a lot of work. This tooling plate does one at a time, but it works for all sizes. So the only thing that I had to make a variety of sizes for is the center spacers. And the other thing to consider is that most glass workers don't really need the lock collars. Most glass workers, including me, have figured out how to manage drift on the NQALHA without the use of lock collars. So there's actually a possibility that maybe I shouldn't even bother, but still, I include 3 of them so that people can have the choice to give them a try and see if they like them. And if they really, really say, oh yeah, I love the lock collar, gotta have it, and by the way, do you make a 19 or a 22 millimeter? Then I'll tell them, sure I do. But I don't include the entire set of 12 with every NQALHA because there just hasn't been that much interest. And when I watch glass workers using the machine, most of the time they don't use the lock collars. So the OD tool path is known and trusted, but I haven't run it for a long time, so finger on the stop button. Single block mode. That's looking sane. Delrin cuts really easily and really cleanly. So yeah, I gotta, when I reset my vices after switching to the rapid turn, I put them in a slightly different place. So my old unload positions are now failing with an error. So I got to go into the toolpath and change the unload position. But boy, this looks like it's working just fine. I'm going to go ahead and run the batch, and then it's going to be back to the table saw where I cut the slot, and in my aluminum parts I cut the slot on the bridge port using a slitting saw, but for this I made up a set of wooden holding fixtures and I cut the slot on the table saw. You know, there's always more than one way to do an operation, and sometimes I do it one way, sometimes I do it another. So see you later. Okay, so the outside diameter has been milled successfully. Here's the fixtures, and like I said before, it's always a question of how much time do I spend on fixturing, how elaborate do the fixtures need to be, and what's the proper method of doing it. Yeah, there's a possibility I could have cut the slot on the router with an 1/8 inch router bit, but 1/8 inch bits kind of scare me a little bit, especially an 1/8 inch bit going through 3/8 material that may not have really, really good chip clearance and may gum up and melt. So anyway, I came up with this solution, which is to cut the slot on the table saw. And the little part, I do need to orient it correctly because I like them to look reasonable. So I put, let's see, how do I do that? Yeah, put the inscription to the left, put it into the fixture thusly, and then before doing that, I'm going to check to make sure that the saw blade lines up So, inscription to the left. The fixture holds the little guy in place nicely. And then a quick trip through the table saw produces that result. So once it's all set up, it goes really fast. So I'm gonna run the rest of these guys and then back to the Tormach for the final drilling operation. So see you later. All of the slots have been cut. Now it's time for the final operation, and this one requires a special fixture, but because of the way the fixture is designed, I don't have to have a special fixture for each of the 12 sizes. They all pretty much work with the same fixture. So the fixture has this little prong sticking out here, and you orient with the inscription down and kind of fit the guy on the little prong like that, which holds it in place. Then close the vise. This tool path has already been tested off camera, so I know it works, and I'm not going to go through the entire process. 0 is set, like it always is, at the rear left corner. Z0 is set at the top of the jaws, the special custom jaws used only for this purpose. I'm attempting to peck with the end mill to avoid a buildup and not succeeding very well. This is a 832 clearance hole going at 5140 RPM. Also pecking to try to reduce buildup, although it's not doing very well. Then I needed to make sure to use a long tap drill. This is the 832 tap drill, and I needed to make sure to use a long one so I'd have enough stick out to avoid running the collet into the part. This means that for many of my drilling operations, I have 2 drills for each size. A short, stubby screw machine drill that I use whenever I can because it provides better accuracy, but when I really need the stick out for clearance, I put a longer drill in. So that does it. The part is complete. It's got a nice little counter bore that gets the screw head below the surface, because when the glass is rotating, the outer diameter of this is very close to the hub of the, let me get it in focus. The outer diameter is very close to the hub of the drive wheel, and so I don't want to have a protruding screw. And then I tap it by hand, partly because of clearance problems, because the tap isn't long enough and I'd run into the collet, and also because I have a clearance hole that acts like a tap guide and it's plastic. Hand tapping is really, really, really fast. So that'll do it for today's video. Thank you for watching.